We're in the Bayport facility at Andersen Windows, and we actually got to go through a factory tour a couple minutes ago, but we wanted to redo it and bring you guys through it because how overwhelming it was. When we think about an Andersen window, we're thinking about buying it from a lumberyard or a vendor or even something like a box store, and what that window is individually. As you can kind of start to see behind us, how many square feet is this facility?
Over 1 million, right?
I think it's over 2 million.
Over 2 million, yeah. So twice that amount. What's crazy about this whole process to me is to see how much machinery and how many people are involved in every single unit is somewhat overwhelming and mind-blowing.
We're going to walk you through kind of some of the highlights that we saw in this tour. There's no way that you're going to be able to capture everything that goes into these windows because even for us being here, it was very difficult to understand every single process. Right behind us, we're in the milling facility for Andersen 400 series windows. They source all of this finger jointed lumber from a manufacturer coming in raw, and they're actually taking it and running it through a series of machinery behind us, and they're producing their own profiles. And the reason that they do that is because they could order it, and some other manufacturers do order this and outsource this part of it, but they felt really strongly that it was important to maintain quality control, with the profiles themselves because of the tight tolerances in which they fit together.
Yeah, so they told us, and I can grab a more complex profile, but essentially they're taking, this piece here is not finger jointed, but typically they're taking a finger jointed pine, and they're creating the molder heads for the profile that they need, and then when they have them cut to length, they're taking this, which is a gauge that's going to be, they call it a quality assurance gauge.
Andersen checks one part at the beginning, middle, and end of each load.
The quality assurance here is to ensure that if this piece doesn't match up, it's going to get junked and they'll recycle it and make it into new finger jointed pine. But if they were to order this or outsource this, they wouldn't be able to control that tolerance there, and it would be a quality control issue. So I'll have Nick hold this. I'm going to grab the molder head and show you a little more complex profile here.
And while he does that, I do want to correct, I said finger jointed pine. And the reason that this is not finger jointed is that this is going to be something that is client facing. So the client facing stuff is not going to be finger jointed, where the structural stuff it would be. That's going to be stuff, the lumber portion of the window that is kind of behind some of the final finish.
So this molder head, this thing is heavy, Doug. This year they will engineer and spec and then create these molders for their machinery to mill the wood exactly how they need it. So for each profile, they're engineering and developing molder heads to cut that specific profile. So here's another piece that, as Nick just discussed, is actually going to get covered with a finish. So it'll get encapsulated completely, and it'll cover these defects, which aren't structural defects here, but you wouldn't want to clear coat this. So this could also be finger jointed, but this is a more complex profile here. And again, you have this quality assurance gauge that they can go and they can test the tolerances on each one of these pieces to ensure that on the ends and the middle, and this is my first time using this, but this will fit onto every portion of this depending on what side you use. So as these are coming out of the machinery, they're going to test to make sure that this is within spec on every piece that comes out. And if it's not, again, they're going to recycle this and then make it into finger jointed pine that they can use on something else.
Through all these machines, you have all this pipe above us, which essentially goes back to what you would consider like a dust collector, but they're producing like 600 tons of sawdust, and less than 1% of that ends up in a landfill, and the rest of it actually gets applied to other product in their product line.
Yeah, whether they're using it in their Fibrex, which is a proprietary product, they're using some of it to heat certain parts of the building, and then also, again, they're going to recycle it. Obviously, they're looking at sustainability.
So this machine here, he's getting all of his rough cut material, putting it into a machine, and what he's got is the computer telling him how long this material needs to be. So we'll go through a series of basically machine parts and get cut to the length in which the order is designed. You can see that this machine can grow in all different directions, and these pieces are being cut very specifically for a particular window.
Here you can see this is the molder that's going to take those blanks of wood, the pine, and it's going to shape them to the parts and the components that they need to make these windows here. From that molder, it's going to kick out, and then it's going to another machine over here that's going to seal that. Wood is very durable, but these windows are going to live outside for a very long time. So they're going to seal this wood with, I believe they switched from a solvent-based to a water-based sealer that they tested, and it's holding up and more durable than the solvent-based sealer. And then it kicks out of them and goes on to the next step of this entire process.
Once it makes it out of the coating, it actually loops around and runs through this oven, which is going to help cure it. And then on this here, you can see them coming out of the oven where everything is drying, being fed out onto this belt. I don't want to get in trouble. Being fed out on this belt, and that's the final product starting on that end over there. And this is where they make a number of the components for the 400 series.
This is still warm from coming out of the oven. So this is like donuts, but this already has that coating applied to it. It went through the oven, it's cured, and this is going to go to the next step in the process.
So he's getting ready to load this up in a car, and where this will go is it will actually go into the supermarket. And this is where we introduce the lean manufacturing. It's really interesting because you think about all of these parts and pieces for, all these different orders for windows, but essentially what they're doing is they're manufacturing in bulk here and then storing them by size and profile in the supermarket. So when an order does come, they're able to quickly source this stuff rather than milling this stuff per order. So why don't we head over there?
To the supermarket.
One of the reasons they have the golf carts is because of the 2 million plus square feet. But as Tyler will point out, you'll see some bicycles with what we think are ice cream coolers on the back.
Yeah, I believe it. You could get snow cones, you could get screw balls, the baseball mitt with the bubble gum, whatever you want. Maintenance guys are riding around on bicycles or three-wheeled bicycles that have tool chests on the back, and that's so they can get from one end of this warehouse to another end without having to walk 300, 400 yards. So they're saving themselves a ton of time. Obviously, there's no pollutants getting into the air with riding a bicycle and an electric golf cart around, so it's making for a safer, cleaner, more efficient workflow in here.
And speaking of safety, I mean, you'll hear the golf cart beep every so often, but there's like very strict guidelines as to where the golf carts can drive. You'll notice that we'll use man doors instead of walking through garage doors. There's pedestrian walkways. In a factory setting with 1,000 people on the floor at a time, you really have to be considerate of the right-of-ways and making sure that people are operating in a safe way, in a safe manner.
You know what? Until you said that, I thought that these people were just beeping at us the whole time saying hi. Yeah. It's like Minnesota is the friendliest place I've been.
We're right outside the supermarket, but this is actually the freeway. And this is, I think, the longest unobstructed view of the warehouse. All the way down there, 500 something yards. Tyler and I are gonna have a foot race later on, see who's faster. But for right now, this is primarily for golf carts. So we were just at milling, and then here in the supermarket is where all of these parts ended up. You saw the cart leave that area, and those carts get staged here. Now, everything is essentially coded with a number. Now, you see this gentleman down here, he's pulling out parts for some sort of order, but the headset he's wearing is actually allowing him to know which parts to pull. I don't know the exact process in which that works.
We'd have to speak to them exactly, but essentially instead of going to a computer and taking down the part numbers that they need, they can communicate with the device on their ear, and it'll tell them what to pull, how many they need to pull for each order. And I believe when they switch to that system, again, rather than going from one computer to another and then getting a printout, they've reduced the number of mistakes and missed pulls that they had. I don't want to say a percentage. It was very high how much they reduced the amount of mistakes that were being made. But what they were looking to do with this supermarket was make it a much more efficient experience for the associate that's pulling this lumber and all of these parts and these components, take out the human error there, and expedite this entire process with fewer mistakes.
So if you can think about it like, where, maybe a furniture store that we might be familiar with, where you go in and you have racks and racks of parts, and you're essentially, in that case, you have a sheet or you have a notepad that you've written down some part numbers. That's essentially removing that, and they're able to, like Tyler said, communicate all through the headset and pull all those parts. Now from here, what they're doing is that's the first start of fulfilling a window order. These are where the parts for the 400 series are staged. So from here, the parts will leave and actually go into finishing. And it's actually a proprietary finish called.
So I believe that the finish itself is not proprietary, but the way that they apply it is. So we can't get into that. The coating is called Flexicron. Anyone can use that finish. I believe they said it's also used on bridges as well, but they have developed a way that they can apply that to ensure that it's evenly coated. They have the proper mill thickness of it, and that they're reducing the amount of waste, because whatever waste there is, it can be recaptured and then reused. I think they said that they use roughly 150,000 gallons a year coating parts on however many millions of parts that go through. One of the reasons they developed this, and we'll get into this when we show you the pieces, but the mill thickness serves two purposes. It's for protection and from exposure to the elements, but also when they mill these parts, they're getting coated pre-assembly. So they have to account for that mill thickness on that joinery, or else it's going to be too tight. So that application of that needs to be very specific. There's a tight tolerance there, just like a rail and style of a door. So that's part of the reason they developed this system.
And it's interesting, like, you hear us calling it coating, and you may be like, oh, they're just painting these parts, and it's not paint. The way it's kind of been described is that paint is more aesthetic, and this is more than just an aesthetic. Yes, it provides an aesthetic finish, but it is very much that protection. And when you think about how it's applied, like Tyler said, we can't really show you the exact process, but you can kind of think about it as like powder coating. It's very similar to that process, which really does provide that even disbursement and very accurate mill layer. So we actually have
not spraying it and getting heavy spots and then some spots that aren't coated. Also, you want to ensure that every part, they're going through the effort of leaving this stuff disassembled and coating it and then assembling it. So the whole point of that is to be able to get into every area of these millings and these profiles. So you want to make sure that this wood is protected on every profile, every crevice, every crack.
By coating these parts separately and then putting them together with a mechanical fastener, like Tyler said, like you're completely coated, you're completely protected. If you have seasonal movement and that opens up a little bit, you're totally fine. Now the argument might come up, it's like, well, it's not as strong, you do need a glue joint. The reality is that glass is going to be part of the structure of that panel. So that glass gets adhered in there with a sealant, and then the mechanical fastening with the screws in the corner. All in all, if any of you have ever removed a sash from a window like an Andersen, you're gonna know that sash is pretty solid. Before we describe what's going on here, the misters actually just kicked on and wanted to call it.
Not to be confused with the misses.
Not to be confused with the misses. The importance of that is really to maintain relative humidity. As wood dries, you're gonna get contraction. As relative humidity kicks up, you're gonna get expansion. What they're doing is they're maintaining the relative humidity throughout the entire process. You're gonna see these misters kind of everywhere that wood is in fabrication, because it's really important that prior to being completely sealed up with this coating, that wood remains very stable for an accurate end product.
They're essentially controlling moisture content. I believe they said around 10%. The factory floor and the warehouses, they're conditioned, but they're not necessarily controlling relative humidity with with a system, with an HVAC system. So they're ensuring that there is moisture in the air, so these parts aren't drying out, cracking, warping, shrinking, twisting, all the typical issues that you would have with wood once it's milled and exposed to the elements.
So you have the raw version, which is essentially you grabbed it out of the supermarket, and prior to getting it into the coating,
they're looking at the appearance of these boards and these woods, and they're ensuring that there's no visual defects in these, but some defects aren't apparent to the naked eye. Once you put a white or a finish on top of that, they become apparent. So what they're doing is they're putting a seal or a coating on these, and then it's UV cured. That's a very rapid process. And then they are hanging all of these parts, protecting the areas. If the exterior finish is separate from the interior finish, they're protecting the exterior, leaving the interior area to be coated and then they're hanging these and they're going through the finishing process there again, so that all of these joints, all of these profiles, everything that's going to have the interior finish gets coated prior to assembly. Some people are going to say that you should be finishing these prior to fabrication, but in my opinion, I would rather have them coated completely and have a mechanical connection, and that paint bridging, everything may crack from day one, but you're not going to have any issues with that joint holding up. It's all protected.
As you see him slide this together, it's a tight joint, but it's actually pretty loose in the terms of how well it stays together by itself, where they're milling that with the assumption that it gets coated. So you can see all raw material, and then we have a coated material here. So our tongue and our groove, everything's coated, and then when you slide it together and you get that nice tight joint, this is going to stay together by itself, and then you do have the whole provisions for your mechanical fastening.
And what would happen is, if you didn't account for the mill thickness of this finish that's getting applied to this, this would be too tight once you milled this and put it together, which would cause issues down the road. It could potentially swell a little more and start cracking. So this fit with the finish applied is what you would be if you built an unfinished door or a cabinet door in a shop. You're accounting for that spray finish on there, so it's a nice, right now this joint doesn't stay together, it's too loose. Once it's finished, it's going to be a nice tight joint.
So we've kind of talked to you guys about how this stuff goes from raw material to a finished material, and what this means is this is an order. These parts are going to some sort of white sash for a double hung. We're going to continue our tour and start talking about the next steps after finish as we look at putting these windows together as a unit. So we're over where they actually form the vinyl sheets. So Tyler, why don't you give us a rundown of what we got going on with this aluminum here?
All right, so these are aluminum frames that are created essentially the same size as the wooden frames. They have air chucks and water chucks, water fittings. Essentially, there's water tubes underneath here, and there's air chucks. So they're taking these vinyl blanks, which you'll see have the nailing flange and everything attached to them. They're one piece, and they have engineered this and determined exactly what size they need for these sheets to lay over these aluminum frames. They then steam them. They are suctioned down to the frame, so they mold and fit this perfectly. Once they're formed, they're gonna have cold water circulate underneath of these, which is gonna stiffen that and harden it, and then they blow air in. There's tiny little air holes throughout here. So these air holes are going to be used to separate the aluminum from the cured or the hardened vinyl, and then they'll drop this entire frame down, and you'll have one solid piece that's completely framed the same size as this aluminum, and then after that they'll go and cut out the center of that.
Yeah, so the important thing to note is that process is only about 40 seconds long.
Yeah.
And before we head over there, one of the questions I had is, well, you have all these frames sitting here, what happens if someone orders a custom size? And that was actually a real problem they had faced, that all of these are the standard sizes. They can produce these on a regular basis, and these are built monolithically with those water and air channels. When you talk about ordering a custom window that's going to have that vinyl exterior cladding, they have the opportunity to build it any size that you want within 1/8 of an inch, and that's done over in their custom area. The one difference there, and the reason why you're paying a slight premium for that, is because they're unable to run the water in it because they're not a monolithic mold. It's put together in multiple pieces, so what happens is that curing process takes a lot longer. So if you're producing less windows per hour, they become more expensive. So why don't we walk over to this machine, because I think it's the most mesmerizing machine. So these are the actual sheets that they use. You can see this is a black color, so it's going to be a black exterior window. And just a reminder, this comes to them in powder form. So this is the back side of the window. If you've ever looked at the back of your nailing flange on a Andersen window, it probably is that color. And these holes here are already pre-punched for that nailing flange. So this right here is probably, obviously a very big window, or maybe it's a double hung, but flat sheet goes over to this machine over here, gets steam formed into its final shape.
The associate here who's going to lift this up, put this on this piece of machinery, and that's going to circle around to that steam bath and that form and that vacuum that's going to suck that down Once that's shaped, it's going to water cool it, and then the air is going to release it from the form.
It's not only the water cool, but they also have 2 fans on top. You actually see in the video how you see the vinyl kind of steaming. Once it's formed, about 2 seconds later, all of the steam kind of dissipates because those 2 fans above that are cooling that down. And when it gets pulled off here, it actually gets stacked up. And obviously that doesn't make a very good window because it still has vinyl on the inside. That will go over to another machine over there, which will cut the window section out in preparation for the future glass. The benefit of using this material is that it can be recycled 5 times.
Up to 5
so
times.
that all of that scrap gets melted back down and eventually turns into another sheet, going along with the sustainability.
Once it's past that lifespan, they'll use it to make their Fibrex. So they'll mill it down, grind it down. So it's not, once they're using it for 5 times that it's done, it goes in a landfill. Once it's done 5 times, it can't be made into sheets any longer. They'll then recycle it, grind it up, and use it for Fibrex. The nice part about this system and this process, it's a monolithic coating on the outside of these window units. So there's no seams, there's no welds, there's no potential points of failure.
So why don't we get over to the assembly line where they're assembling the wood frames, and these vinyl bucks essentially get applied to that prior to the sashes being installed. So from the supermarket, these are all the raw parts that are brought up here to where we're gonna get into the final assembly. So you go to the supermarket, the parts get collected and organized, and this is also where the vinyl covers show up.
If we go over here, you're gonna see on this cart are all the components of the windows that they're going to be placing the cap on. So he's gonna come and he's gonna pull, he has head sills, he has base sills, there's posts, the sides of the frame are on here. He's gonna pull these over to the table. So you can see he's dropping all the parts of that window frame on now. The posts are going in, the center posts, the sills, the top and bottom sill, and both sides of that frame. And then he'll grab that vinyl cap that he's gonna drop onto it. So you can see it's stapling it off. The neat thing about this is it's stapling from both directions. And when we came in toward this earlier, they said this is mitigating the issue of multiple employees firing multiple staple guns in directions at each other at the same time. So it's stapling in 2 directions at once.
Once it comes out of there from being stapled together, that wood frame comes out, and he's gonna inspect that frame to make sure everything was stapled and fastened properly. And he's gonna spin around and grab one of these vinyl frames.
To the left of me, Andersen is applying a proprietary adhesive. It's applying that adhesive evenly throughout the vinyl, and once the adhesive is pressed onto the wood buck, it creates a permanent fixture between the vinyl and the wood frame.
And he's gonna put a sticker on it that's gonna outline all of the information in terms of which way those casements are gonna swing and be hinged, and the hardware specifications. It's gonna go into that final section here, which essentially adds a ton of weight and rolls that vinyl cover on.
So that entire frame is coming out through that conveyor belt, and they're going to look at that ticket that has all the description for how this window is being assembled, the hardware types, the finishes that are being used. They're going to start putting on locking mechanisms, the operators, and then it's going to go over onto these tables. In order to increase efficiency and be as ergonomic as possible, these tables are actually going to flip 180 degrees, and they can always be working at a comfortable level and height for them. Everyone has the opportunity to switch jobs every 2 hours, so this doesn't become too monotonous, too mundane. Also, if somebody has a sick day, they have people who can fill in and perform multiple roles, so they're not going to be a hang up in this assembly line.
We constantly battle burnout. We constantly battle the, what if someone is sick, or what if someone leaves your company suddenly?
Or I can't miss work today because there's nobody to fill my role.
Right, and it creates this unnecessary anxiety where, something as simple as rotating their positions every 2 hours gets the wheels turning, in the sense of like, maybe we bring this to our companies. Maybe we have our team kind of explore different roles within the company so they can not only fill different shoes, but have the ability to kind of spread their wings and explore different opportunities.
Yeah, I have to be completely honest. When we were touring this entire facility, I know you were the same as me in this sense, that I just kept thinking, I cannot imagine doing the same thing for 8 hours a day every single day. And when they told us everyone has an opportunity to switch every 2 hours, I had a massive sigh of relief. It was like, oh, thank goodness. They have an opportunity to move on and try something else, so they're not just stuck doing one thing over and over and over.
Once it comes off that assembly line where everything is vertical, it gets over to this table here, which can be oriented vertically or horizontally, depending on what kind of sash they're putting in. But speaking of sashes, you see the cart behind here, the white one, and it's on top of this blue, essentially what looks like maybe a pallet. And you can see as he presses the button, it actually lifts it up. And that's designed to be more ergonomic and make it more comfortable for them to work. So as they're working through, you see the table lower down. They're going to grab 2 of those sashes. They're going to drop them into the pre-applied hardware, and they're doing it very quickly. I can't help but kind of laugh because I think about the times that I've been on a job site, taking apart a window that broke, adjusting hardware, switching hardware, and how complicated it is. And you spend hours and hours and hours trying to understand the way that they've done it in the factory, and watching them do it, in such an efficient way. What they've done is they've removed a lot of the complexity by building these systems, building these processes all the way throughout. So that window can be made extremely efficiently. Everyone is working in a comfortable environment, and it just makes a lot of sense. As they're coming down this line, you'll notice some of them have fixed units in it. The fixed units are actually pressed automatically from below. If there are fixed units, they actually automatically are fed down in the back, fed underneath this table, and then pressed up and then clip into place. Everything that you were seeing being installed by hand and by everyone on the floor were operational units. Something interesting to point out, so this just came off. It's sitting on top of rollers here, but as it makes its way down, it's actually going to go from being on rollers to these wheels where it actually captures that bottom edge of the pine. And the reason why I feel like that's interesting is it kind of continues to support the standardization of parts, where these windows are customizable. You can order any size, but there's standardization behind some of the parts because they have to be able to operate and go through the assembly line in a particular way. And this is where you think about how you can increase efficiency in traditional building. I've said this before, you've heard me talk about off-site construction. Here's a great example of something that was built on site. Windows were glazed on site at one point, and they are no longer done like that. They are glazed in a factory, boxed up and shipped to your job site. We could be thinking about the processes that Andersen implements here on the factory floor into other parts of the way we build.
I have to admit, this is probably my favorite part of this whole process.
Your favorite part?
Well, if you've ever taken something out of a box before and then needed to return it, I cannot get it back into the box. So their ability to get this into a box in the first place is impressive.
But they have this, I've been watching it, and they have this aluminum roller.
That's
which
what
you
I
can see
need.
At the end of the table. We need an aluminum roller to, when we have to make a return because one of us ordered a window the wrong size, we can get it back in the box.
So you can see they have the styrofoam in there protecting the window, the nailing flange, and then the cardboard, and then they're stapling that entire box off so that can get moved over to one of their other facilities for distribution.
Basically start to finish assembly of these windows. We do have one more thing that we want to show you, and that is a single piece weather stripping. So follow us. What we're looking at here is weather stripping, and it's fed out of a large spool. It's installed around the entire window in one piece, and at the very end, Tyler, you said they scarf joint.
Essentially, I'm thinking from carpentry terminology, but they're gonna have an angled joint that's gonna join this at a specific location based on the type of window. So for an awning window, it's gonna be different than a casement, but essentially they figured out where the area that's gonna be prone to the least exposure to the elements that they're gonna put this joint.
Before they did this in one piece, it was done in 4 pieces. All of your seams at your corners, and your corners are the most vulnerable part of weather sealing.
So having one piece around the corners is going to help immensely with that respect.
Yeah, a great improvement to their system. We covered such a high level view of this. There's 1,000 people in this warehouse today, and over 2 million square feet. I mean, there's a lot going on. There's a lot of different sizes and things being built, but this gives you an understanding of the things that they're thinking of, just like that single piece weather stripping and that single piece vinyl protection layer on the outside of the window really shows the commitment to quality, but also the commitment to sustainability in all of their recycling efforts.
Yeah, there's a lot of people, a lot of processes, and a lot of equipment that goes into every single window that comes out of here.
Hope you guys enjoyed it. Let us know in the comments.